I'm Anil Kumar. We'll explore unit step functions in some of these videos now. There's a very famous function which we'll talk about. The Heaviside function h of t is used to study electric circuits to represent the sudden surge of electric current or voltage when a switch is instantaneously turned on. It is defined as h of t equals to 0 for t less than 0 and h of t equals to 1 for t greater than equal to 0. Sketch a graph of the function and state its domain and range. That's the question for you. Right, so let's talk about this function a bit. Let me sketch this first. So whenever you put the switch on, all of a sudden the light comes on. Earlier it was all dark. So think like this. So before switching it on, it was all dark. So we'll say like this, a hole here, and this is what is h of t equals to 0 when t is less than 0, correct? So this is my function h of t, and here we have time t. Okay. Now as soon as you put the switch on, the current starts flowing, and that's what we say a surge of electric current, right? So, and also the voltage is there at those points, correct? So immediately the switch is on. So it goes from 0 state to 1 state, like this. Now this circle is actually filled in because you have greater than equal to. So that becomes the graph of the function. Now let's write down its domain and range. So the domain here is, we'll say t belongs to real numbers. So there is no restriction on domain, right? So t is all real numbers. But as far as the range is concerned, so h of t, which is y in this case, is either equal to 0, right? Or it is equals to 1, right? So these two values are 0 and 1. So that is what this function is. Now in electrical circuits, what we do is we try to measure current and voltage and use this function to represent them. For example, now let's take an example, kind of extend this portion to it. Let us say I apply a voltage of, let's say 110 volts at t equals to 0. Then how can I represent this voltage with the help of this function, Heaviside function, right? So we could always write in terms of this 110 at t equals to 0. So we could write this as the magnitude gets multiplied by 110. Do you see that? So it is 110 times h of t. Do you see that? So that is how you could actually use this function very easily. Perfect. So that is a good application, and it helps to solve some electrical circuit questions. Now, if I apply, this is case A, let me write down here A, and let me give you another scenario. If I apply the voltage V of t at t equals to 5, then how can I write the voltage in terms of this particular function? Can you tell me that? And the voltage again, let's say 110 volts. Okay, so 110 volts is applied at t equals to 5. How can I write or express this voltage in terms of Heaviside function? You can pause the video and answer this question. Here is the solution. So in that case, since we are applying it at t equals to 5, so till that time it is 0, right? So the function kicks in to 1's value where t equals to 5. That means it could be written as it is 110 when we can write this as h of t minus 5. So we have moved it 5 units to the right. Do you see that? So that becomes the value of the function, and it could be represented as equals to 110 volts when t is greater than equals to 0, or it is 0 volts when t is less than 0. Does it make sense to you? So that's an application for this particular unit function, unit step function. I'm Anil Kumar, and I hope that helps. Thank you and all the best.